So, welcome to the stream. My first my first viewer is online and even active in the chat. Hello, Tony. So, let's get started. Rock, paper, scissors. The elves begin to set up camp on the beach. To decide whose tents get to the closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between two players. Each game contains many rounds. In each round, the player each simultaneously chooses one of rock, paper, or scissors using a hand shape. Then a winner for that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play, A for rock, B for paper, and C for scissors. The second column, dash dash, suddenly the elf is called away to help with someone's tent. The second column, you reason, must be what you should play in response: X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious for the response, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected, 1 for rock, 2 for paper, 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide: A, Y, B, X, C, Z. This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock and you should choose paper. This ends in a win for you with a score of 8, 2 because you chose paper, 6 because you won. In the second round, your opponent will choose paper, B, and you should choose rock, X. This ends in a loss for you with a score of 1 plus 0. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3. This is 6. In this example, if you were to follow the strategy guide, you would get a total score of 15. 8 plus 1 plus 6. What would your total score be if everything goes exactly according to your strategy guide? Yeah. So already a bit more difficult than the first day, but let's start. So we can increase the font size here, I think. Control Alt Shift Top. No. Let's Control Alt Shift Plus. Yeah, very good. So then let's create our level 2. And don't need this anymore, don't need this anymore. And for our first example, we'll get our example input, put it in there, and we check it against the score. This is the 15, and we put that into our check file. And for the my input file, we get our puzzle. This looks pretty good. And insert So delete this for now, and then we create the puzzle for the day, which is puzzle to 0. Yes. And we also want to run our puzzle. This we don't no longer need. And this is also. So, go away. We get our lines as we did before. So let's just read our lines. And we can start by separating the two hands, and we can separate them by splitting it, and we can split the line with space because that's what's between. And we should get two elements here, so we'll keep that. Well, hands, this we store in a variable, and then we set the opponent to hand 0, and my hand will set this to 1. So we pick the first one here, second one here, and then we'll need to should we translate this? We can keep it as it is. Yes. The thing what makes this a bit more difficult is that we'll need to that we have different symbols. So we have the Y for paper for ourself, and we have the B for paper here. But yeah, leave it like this. We'll check now for a draw. So if the opponent is equal to A, and our hand is equal to X, then we have a draw. This is obvious. So this is one of the draw conditions, and another of the draw conditions is that we choose a B, and the opponent chooses a B and we choose a Y. And another draw condition is that the opponent chooses a C and we choose a Z. And then we have a draw here. We'll also introduce a variable for counting our score, which is set to 0 before, and we'll make a variable here for the game score, which is also 0. And in case of a draw, the game score, we add a 3 to the game score. Then we have the conditions where we win the game. Let's do it like this. So if we choose, let me check, the X is a rock and our opponent chooses the scissors, then we win. If we choose the scissors and our opponent chooses paper, which is A, no, which is B, and we choose, that doesn't work quite, Y is paper for us. So if our opponent chooses the rock and we choose the paper, then we win. And if we choose the scissors and our opponent chooses the paper, which is then B, then we win. So in this case, the game score, we add 6 to the game score. This is exclusive, so either this happens or this happens. And if we lose, we add 0, which we can actually skip. And we also get an additional for one for rock, two for paper, and 3 for scissors. And we can add this with my hand. My hand. Yeah, we get 1 for rock, 2 for paper, 3 for scissors. We could actually do it the fun way. We add the game score of the my hand, which is and we'll take the character, the first one, and we subtract the character of X. Because in computers, all the letters are represented as codes, and those codes have numbers, and if we subtract an X from a Y, we'll receive 1. And if we subtract X from X, we'll receive a 0. We add the 1 because we have it here. And we'll get the 2 for the paper because this turns out to be 1. And we should also get the 1 for the, it's the last one, the scissors. Not the easiest solution, but a more fun solution, I think. And afterwards, we add the score to the game score. And the game score should be our final output, which is the score. The game score is the score within the, let's call it round score. Round score. So we just see if this works. And we run our puzzle part 1. So we have the correct solution for our example input because we automatically verify what against this one here. And this is the solution we get for our, let's see if, for our input, let's see if it's correct. Whew, at least that. And let's go to part 2 now. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above now goes like this. In the first round, your opponent will choose rock A. You need the round to end in a draw. So you also choose rock. This gives you a score of 1 plus 3, 4, and so on. We'll now have an 12 as our solution to the example data we have here. This means for our grid here, we just copy that, call this P2, everything fine, and we'll now update this to 12. Let me just double check. Yes. Good. That means some changes for us, but maybe not too many. We'll see. We'll copy over the content of this method to our puzzle 2 here. And we also should run our puzzle 2 here. That means we'll check this to puzzle 2 or to part 2, puzzle 2 anyhow, because the second day today. Yeah, we do the same, but now this one here needs to be changed because we now don't know the hand any longer. That means we now need to transform this. And we can actually, how should we do that? Maybe we can. Let me check. Yeah, let's do that with some ifs though. It's a little bit more to code. We will now just leave whatever we did here. I think we could make it easier because we don't need to check this. We only need to check if we should win the round. But well, one can keep it. So now this is now not longer our hand. This is the end of the game we want to know. And if the end of the game is equal to x, then we need to guess our hand for ourselves. We'll just say, well, my hand. This is something we get out of that then. And if we have the x, we are supposed to lose. That means if our opponent chooses a rock, we need to choose, we have a nice listing here, rock, paper, scissors. We need to choose scissors. If it chooses paper, we need to choose rock, we need to choose scissors. If we choose paper, we need to choose rock. And if we choose scissors, we need to choose, no, if he chooses scissors, we need to lose. If he chooses scissors, we need to choose rock. This would be in that direction. Yeah. So, if the end of the game is an X, then we want to lose, and our opponent hand, if our opponent hand is an A, that is rock, then we want to choose the scissors, which for us is the Z. If our opponent chooses the paper, we want to choose the rock. And the rock is our X. And if our opponent chooses scissors, we want, if our opponent chooses paper, we want to choose, no, we don't choose. This is pretty complicated thinking of it actually. So, if opponent A has the rock, we want the scissors. Yeah. If opponent B has the paper, we want the rock. And if opponent has the scissors, we want the paper. So it's actually relatively hard thinking of losing this game because you kind of tend to do the opposite. Then, if the end of game, it should be draw. Is it X? Y means you need to enter round in a draw. That's easy because in this case, the only thing we'll need to do is we choose the same as our opponent did. And we'll pick this one. Then we need to choose, if our opponent chose A, Then we'll need to choose rock. Then we need to choose paper. If our opponent chose paper, we need to take scissors. And yeah, in the other case, if our opponent takes scissors, we need to take rock. So whatever that is, don't need this anymore. And this now should give us the my hand. And we'll just keep this here. What does it recommend? Now we'll see. End of game Y. Yeah, that actually seems good though. This is end of game, and we still use them. But why does it condition A and is always false? This is something that should not really be the case. Maybe this thing is just not working. Let's give it a try for the example. So we had a wrong solution. Yes, I think so as well. I think we have something wrong here. You take the end of game. Can give it a try. Let's see what our debug says. So we get the hand of our opponent, it's A, and we get the end of the game, which is Y. And Y basically means we need to win this. Oh, no, Y is a draw. Yeah, fine. And our opponent has an A. We would also, my hand would also be an A, right? A and A. And we didn't put it in there because we don't get any additional score for this. So that's fine. So next game, the opponent takes a B, rock, which is paper, and we need to lose. Is it yes, we need to lose, and we need our road, and we need to lose against paper, so we need to choose the rock, and the rock is an X, which we do, but what's our total score? We should have gotten 3. Yeah, I think this thing here is not really working now. Don't really know why actually, because we even have a score of -22, which does not really make sense. Why can't we use this here anymore? Interesting. The round score. Let's try this. And we get a 1, and we lost. That also makes sense, but I'm still not happy with the first thing we had. Because let's just rerun it. The minus 22 must kind of come from this situation here. But why does my hand? We are not allowed to do this. Yes, obviously. So yes, indeed, we need to choose the same symbol. We need to choose the same rock, paper, or scissors, but we are like not allowed to just copy it because they use a different encoding. So if our opponent chooses A, we need to choose X. If our opponent chooses B, we need to choose Y. And if our opponent basically the other option, then we need to choose Z here. And with this, of course, we have an A. We subtract minus X, and X is the 24th letter of the alphabet, and if we subtract that, we'll end up with minus 22. Or almost with the +1 then. So yeah, that makes sense that this is wrong in that case, yeah. So we got the correct solution for our example now, and this is now my proposed solution. And let's see if it works. Yeah, it worked. At least that. So thanks for tuning in. Thanks for tuning in, Tony. And yeah, see you sometime. Bye bye.